Hey there. Welcome to my little slice of heaven up here in New Hampshire. Thank you all for joining me tonight. Hopefully we're going to have some good questions and some good discussion as we talk about cranes and the basics of crane work involving trees. So before we get too far into it, for those who don't know, my name is Travis Vickerson. I'm Vice President of Operations for a company called Chippers, Inc. We're a New England-based tree care company, dealing in everything from PHC, turf care, tree care, maple syrup, landscaping, and a little bit of everything else. Do a little bit of everything, operating in Vermont and New Hampshire. I'm also a TCIA trainer for the Tree Care Academy series, tree care specialist, and also was the co-author of the BMP for crane work for tree care. So luckily enough to be in the right place at the right time to help write this material for the industry. So that's a little bit about me. As you can see, we have my nice crane here next to me tonight. It's going to give us a little bit of ability to work on some crane stuff, talk about some crane stuff without having to actually be outside in where it's currently about 5 degrees here. So I'd like to stay inside if possible. So with that, we're going to kind of hop right into things. I've got a little bit of PowerPoint to go through as well. So if you do have a Tree Care Academy Crane Operations Specialist book, feel free to get that out and go along with us. We're going to go through all 9 modules of this program and kind of give you a little bit more information than just the text gives you. So that's kind of what tonight's going to look like. We're going to hop right into it. So the 9 modules that we're going to cover tonight are job site safety, electrical hazards, safe lifting, setup, slings and connectors, the operator, the rigger cutter, the ground crew, and rigging and hoisting. So those are all 9 of the modules located within the Tree Care Academy series. And we're just going to go through all of those one at a time here and kind of get those looked at and a little bit more in depth. I'm also have the live version up as well on a separate computer. So as you guys ask questions, hopefully I'll be able to answer them in a timely fashion. So you guys aren't waiting for your questions to get answered all along. If you have a question though and I don't get to it, be patient. I'll ask for questions again. I know Daniel Ladowski, sorry if I mispronounced that, already asked a question earlier about detecting voids and unstable. So we did a test run, folks, at 4 o'clock today, and it worked perfectly. And we all said that as soon as we start, this is going to go bad. And clearly it is. So Kayla is working diligently to fix it, so just hang with us for a few more minutes. All right, can everybody hear me all right? I'm getting some people making some comments about this. All right. Still echoey, folks? I see your comments in there about being echoey. Are we good, folks? Oh, somebody said the marijuana is kicking in. Well, maybe for you, not for me, but, to each their own.
Oh, it says the guy in New Hampshire. All right, we should be good to go now.
All right. So hopefully that solves the echo. I apologize for that. And we're going to hop back into it. So job site safety, we're going to look at the top 4 incidents in tree care. All right. And those incidents being what involves fatalities as well as injuries. Obviously, we all know the number 1 incident in our industry is struck bys. That's struck by whole or parts of trees coming down. That is the leading cause of fatality currently. It's also the leading cause of injury in our industry. The numbers I had heard was that there had been 149 fatalities this year in the tree care industry. Now, there was another number thrown out earlier in the year, about 178. We believe some of those may have been homeowners, not necessarily tree workers. But either way, we're averaging 1 worker killed every 2.5 days, which is crazy to me. There's not that many of us to start with, and losing that many just seems baffling. So number 1 cause is struck bys. Number 2, number 1 cause of injury, not fatality, is slips, trips, and falls. Now, obviously, in the fall category, we also include falls from trees, falls from being suspended. And we're going to talk specifically about falls in relation to crane work and some of the regulations that come in from the Z133 in regards to how to hoist a climber correctly and how to hoist a climber safely. Then we're going to talk about electrical contact and how it relates to tree care and cranes and some of the specifics about that as being one of our incidents. And then our last incident is vehicular. That is either driving to and from the job site or being struck by on the job site. So those are our top 4 incidents in tree care in relation to injury and fatality. So a little bit of a mixture there. We're not looking at just fatality or just injury. We're looking at a little bit of a mixture. And we have to figure out what we can do to prevent these injuries. Again, with fatalities every 2.5 days, we've got to do something different. What we're doing currently isn't working. We still have people dying. For me, it's a personal thing. I lost a friend quite a few years ago now, but it's still hard. That fell out of a tree doing tree work. And these are all incidents that can be avoided. I don't call them accidents. I call them incidents because an incident is just that. It's an avoidable thing. An accident implies nothing happened that you could control. But I've never had a tree come to my door, knock on it, and punch me in the mouth. I've always done something that's resulted in an injury to me. Okay. Inside job site safety, we're going to talk about PPE. That's one of the ways we can control some of these incidents. We're going to talk about job briefings and communication. And, I understand this. Not everybody loves PowerPoint, but we're going to go over the PowerPoint because I want you hopefully to take some stuff from this and be able to go back and watch this later on with the tree care crane operations specialist and answer some of the questions. So PPE, we know the number one thing we have to wear at all times is helmet, eye pro, ear protection, footwear, chainsaw protection, and then high visibility clothing when exposed to traffic. 2 different types of helmets in the industry. We have Class E helmets or non-E helmets. One being you can work within the 10 feet minimum approach distance electrical power, and one you can't. That's the only real difference. Obviously, we need to make sure our helmets are in accordance with ANSI standards and have the decal inside the helmet or the stamping inside the helmet so they're valid. Also, follow your manufacturer recommendation in regards to lifespan of the helmet and when to retire a helmet. For instance, earlier this week, I had one of our workers who slipped on the ice. He fell and ended up in the ER with a concussion. He was wearing his helmet when he fell, so we've since retired that helmet because it's considered an impact. We retired that helmet. We're going to purchase him a new helmet now because he did have an impact. No, it wasn't a fall of a tree and nothing hit him in the head, but he still impacted the ground enough to knock him unconscious and get transported to the hospital. All right. Obviously, eye protection is key. Ear protection. With the ear protection, you need to make sure that it's ear protection that's going to protect you from the decibel range we deal with. And that's 85 decibels of a time-weighted average. That means 85 decibel average over an 8-hour workday. So a lot of times I'll hear people say, I just put my ear protection in when I run a piece of equipment. Well, that's great, but you really should be taking the amount of decibels you're producing for the entire 8-hour day and averaging that out. And if you're exceeding the 85 decibels, you need to wear your ear protection the whole day. Chainsaw protection. It's one of the greatest things that's come into the market in the last few years is the ability to have better, more comfortable chainsaw protection. When I started this industry 18 years ago, chaps was pretty much the only option that you had available. And then slowly over time, we started getting chainsaw pants and chainsaw, trousers and those kind of things. And they've evolved from what the first models, which were like wearing snowboard pants, to now some of the lightest material on the market. I personally wear the Clogger Zeros, and I almost don't even realize I have chainsaw protection on because they're so lightweight, so comfortable. So nothing wrong with chaps. It's purely a personal preference or a company preference. At Chippers, we have chosen to outfit all of our employees with chainsaw pants versus chaps because I want to make sure that they're wearing them at all times. There's no risk somebody's maybe not have their pants on when they come to work every day. We know if you come to work, you got your pants on. At least we hope so. So that was one thing that we chose to do as a company to help with that versus, putting the due diligence on the employee to put their chaps on or take them off if they're chipping and those kind of things. But again, what works for one company doesn't work for every company. There is no right way to do this. There's just a few wrong ways. So find out what works for you, find out what works for your company. Next, we're going to talk about job briefings. All right. Inside job briefings, as you can see in the slide here, there's a template of a tree site visual assessment checklist that TCIA puts out. You actually can get this. It's in the back of the Tree Care Academy series book. But this is just a standard job briefing form, very basic. It's got a bunch of check boxes, got some fill in the blank stuff, but it allows you to do a verbal job briefing and document it for every work that we're on. Ironically enough, in the current Z133, it does not require that you do documented job briefings, but it is requirement of OSHA that you have to be able to prove you did a job briefing. So the way we prove we do job briefings is by documenting them. I'm a part of several task groups in the Z133, and hopefully in the future, we're going to be changing the verbiage there and actually making it where it is a requirement to actually do documented job briefings for all jobs. Nothing wrong with doing verbal ones, but in the eyes of OSHA, if you didn't write it down, it didn't happen. Also, we're going to talk about communication tonight. Some of the communication we're going to talk about is hand signals. When dealing with crane work, hand signals are very vital. Though we have this great Bluetooth communication available nowadays, a lot of times we still revert back to the hand signals. And there's some hand signals that are accepted and some that not necessarily are. One little trivia fact is OSHA requires that all job sites have a visible hand communication placard, decal, visible. The way most people get around that is they actually leave it placed on their crane that they buy from the manufacturer, and therefore it's on every job site. But you're actually not technically required to have it placed on your crane. It just has to be on the job site. All right. So what you're seeing on your screen here obviously is not the correct hand signals. However, I need a hug. That kind of happens every day. Sometimes I need some hugs. You know, not time to do the thriller dance. You know, there's some things out there that are not approved hand signals. But what you're looking at in the next slide is actually approved hand signals that are the most common in tree work. And these are the ANSI approved hand signals that fall in accordance with the OSHA 1910 standard. Or, you all right, Cal? Cal? Okay. Sorry about that. The hand signals that we're going to talk about are the approved hand signals by ANSI, and that also come from the ASME B30.5, which is the crane manual for how we do work with construction. And since we are using a crane that is a construction tool, sometimes we have to follow their standards as well as our tree care standards. So obviously the first hand signal is pretty easy. Hoist. Hoist up, hoist down. If you put your hand over top of that, it becomes hoist slow up, hoist slow down. It allows the operator to kind of know what speed you're looking to have the hoist run at. Next, we're going to talk about raise boom and lower load, which is this hand signal here. When you give this hand signal, if you can watch me here on the crane, if I just lower my boom, my piece actually comes down with me and drifts at an angle. All right. But if we want to leave the piece right there and float the piece, we're actually going to need to boom up and hoist down at the same time. This allows the piece to float inward without gaining any altitude. And the same thing works going the opposite direction. We can hoist up and boom down, and this allows the piece to float. This is very helpful when especially moving pieces towards a chipper. If we're trying to float this piece into the back table where the chipper, the hopper is at, we don't want our boom coming down and dropping the piece. We want to float the piece in horizontally. So in order to do that, we have to give the right hand signal of boom up, cable down, or boom down, cable up. Hold on one second. My computer stopped working. There we go. All right. Next, we're going to have swing. Swing is in relation to which way we want the crane to turn, left and right. Try to avoid putting the signal directly in front of your body. A lot of times as an operator, it's very difficult to see that motion. We want to make sure it's very visible left and right of the body. All right. So don't be giving signals such as this. It makes it very hard for the operator to see, especially at a distance. And if you're wearing black attire like I am today, it'll be very hard for an operator to see that. Hopefully I'm wearing my high vis, it'll be a little easier, but still make the motions very dramatic, make them very big. Emergency stop is a hand signal that has to be obeyed no matter who gives it. So as crazy as it may sound, the postman can walk onto your job site and give this signal and things have to stop. That's the emergency stop sign, and by OSHA regulation, we are required to follow that, and it can be given by anybody. The last few we're not really going to talk about in relation to this crane here. One of the ones that's in there is called travel. It's given this motion, or you can do this motion if it's a crawler crane. The crane we have here for the demo today is a boom truck style crane. All right. We're not really going to be traveling when the boom's up in the air with this crane. But if we had a rough terrain crane that had what's called pick and carry capability, where we have the ability to actually pick our load and then pick our outriggers up and drive with that load, That's where travel comes into play. That's where we want to maybe say, pick the load, and we're going to travel with the load. All right, so that's what that's in relation to. Most operators, generally speaking, once they've extended their boom to the right length they need to operate from, don't like retracting and extending their boom back and forth throughout their operational period. They like to leave that set. I'm the same way as an operator. If at all possible, I want to get my boom length set, and I want to leave it there. And I just want to use boom up, left, right, and cable up and down, and not really do a whole lot of retracting and extending, especially when we have a load on that. When we have a load on the system and we're pushing or retracting our boom, it's because a lot of wear, causes the wear pads to wear out, and it's very difficult on the crane itself. Also, if you're not careful and you have a new operator, as you extend the boom up and they don't cable down, the cable goes up. If you continue to do this operation, you eventually will do what's called tube blocking. So let me reset this here for a second and back up. So if our load's sitting right about there, so we're pretty close to the edge of our sheave here for our boom, where our tip's at. If we were to extend this, as you can watch the tube block, the block here, it's going to slide on up into the sheave. Eventually, the block's going to reach the sheave if you don't have a properly operating tube block control, and it's going to actually pull that up into there, damaging the crane, and you actually run the risk. This could actually come off the side, and you could end up with a load being suspended from the side of the crane, side loading the boom, and thus failing the crane. So we really want to make sure if we are going to extend and retract that we're making sure we're letting out hoist wire at the same time so that we can make sure we don't tube block our crane. Tube blocking the crane is when you put the block at the point sheave. It's called tube blocking. So most cranes have a tube block indicator. That tube block indicator suspends down from the load line, usually about 6 to 8 inches. In the event that the tube block were to reach that, it picks up the weight. That weight obviously fires off an electrical connection that alerts the operator to stop what they're doing. And in some cranes, actually stops all operation until it's overridden. All right, so that's there for our safety. We want to make sure that's working properly. So those are some of the hand signals that we deal with mostly in tree care. All right. Luckily, nowadays, we have radio communication. Radio communication has greatly improved how we do our work. It's also improved the ability to do work with cranes. So now as an operator, if I'm doing the cutting and climbing and I have my chainsaw here and say I'm making my cut, I don't have to take my hand off my saw at any point to give any kind of direction as far as boom up, cable down, hoist down, boom left, boom right. I can keep my hands on the saw at all times like I'm supposed to and talk to my operator through Bluetooth communication systems. That allows for much more clear and concise communication with our operators and lets them not have any question as to what I want them to do. I can say, just, hey, cable up just a little bit, cable down a little bit, swing left, swing right. Makes it a little bit easier and also keeps me having both hands on the saw at all times. We're not going to get into that debate tonight about the two hands on saws. That's a whole different conversation. But I prefer to keep both hands on my saw at all times, no matter if it's a top handle saw or not. And having the Bluetooth communication allows me to speak directly to my operator and my ground crew without having to take my hands off the saw. So that's it for the first module. Pretty easy, not a big deal. I think it's only a few pages. But next we're going to get into electrical hazards. All right. Before we hop into electrical hazards, though, is there any questions in relation to Module 1?
I'm not sure that we have many questions about Module 1. The one thing I know we were kind of joking around here was talking about remote controlled cranes and whether or not you need a spotter with those, how you would deal with spotting on when you have someone actually on the ground in the area looking at what's going on and controlling your boom and everything.
So in relation to spotters, especially knuckle booms, and I see Stephen Connolly's on here, and he's one of the industry experts when it comes to knuckle booms. So I'm really glad Stephen's on here, and he can help answer some of these questions as well through the comment section. Where spotters come into play is both for knuckle boom cranes as well as load line cranes, and that's in relation to electrical hazards. Anytime our crane is going to be approaching the minimum approach distance of 10 feet, we need to make sure we have a spotter available. That spotter is a dedicated position. They can't be doing traffic and spotting. It is a dedicated position so that the operator knows at all times where either their load line is at in the of a load line crane like this one here, or a knuckle boom crane. Make sure we know where that knuckle is operating at and all that. Luckily, with the ability to have remote control, the operator can kind of work as their own spotter. That works for a lot of companies, and there's nothing wrong with doing that. However, I would still recommend when we're operating within that minimum approach distance, or when we're operating close to that minimum approach distance, we still have a second set of eyes watching everything, especially with knuckle booms. There's a lot more going on with the boom itself as far as where the knuckles are moving at. And we want to make sure that we're maintaining our minimum approach distance and not putting anybody in danger. Does that answer the question there? All I can see is the pinned comment right now, so.
My bad. I'll try to keep you up to date. Pretty much the other thing is someone is talking about tube blocking. I don't know if we're going to get into that later or if you want to address that now.
So, tube blocking, and I'm sorry if you guys couldn't hear me, but I said tube blocking. It is tube blocking, TWO blocking. That happens when the block, which is the piece that hangs below the wire, comes up top to the point sheave on the crane. The boom point sheave, which is the very first sheave where the wire comes off, when the block reaches that, that's called tube blocking. Tube blocking is very detrimental to cranes, very dangerous, causes a lot of damage. Most cranes have a tube block indicator. That tube block indicator is a weight that hangs down below the load line, entrapping the load line, and it's on a sensor. When that weight gets picked up by the block coming up this way, that weight triggers a series of electrical connections down to the cab, which alerts the operator that they are tube blocking the crane. So that is in relation to tube blocking, not tube blocking.
Gotcha. All right. Thanks for that. I think we can keep on going.
All right. For whatever reason, all the comments I can see on my screen are the pinned comments for whatever reason. But that's all right. All right, so moving on. Section number 2 is electrical hazards. I kind of have a personal issue with electrical hazards and people getting injured by them. Electricity is kind of like a railroad track. You only get hit by a train if you get in front of the railroad track or get on the railroad track in front of the train. The train doesn't leave the railroad track to hit you. Electricity is very similar. Electricity only hits you if you get in its way or you put some object in its way that you are touching, thus being indirect contact. We know electricity is present on pretty much every job site we operate on. Yet we still have people getting injured and having people killed. As you can see in these two pictures here in the slide, we have one operator here who has a phone line in his mouth. He is literally chewing on a phone line while he makes a cut. Now, some people say, oh, well, that's a communication wire. It's not power. Just so you know, NIOSH released a report a few years back that says communication lines have 49 volts of electricity running through them. Now, obviously, amps are what we worry about when it comes to fatalities, not volts. But all amps are is ohms of the volts divided by ohms of resistance. Your mouth does not have a whole lot of ohms of resistance being a wet environment. Putting a phone wire in your mouth is a good way to get killed. Though it's only 49 volts, if you're able to bite through that sheathing and make contact with electricity in that wire, especially with some of the new communication systems that are being utilized in businesses that are running on higher voltage, you could have a fatality. The lethal limit reported by OSHA is 50 volts. So NIOSH comes in right at 49 volts, right below the lethal limit, which is 50 volts. And if you, like this individual in the picture, decide to put a phone wire in your mouth and bite it, I kind of look at that as natural selection. Don't do that or you end up like the guy on the right side. The guy on the right side made indirect contact with the primaries through the piece he was rigging. Piece came down, connected with the primaries. He grabbed the piece, and thus you can see the result. So electrical hazards are something that are always present in almost every job we deal with and become a big issue with cranes. Cranes, in their own essence, are giant lightning rods. They're not grounded. They're not insulated. They're big pieces of metal that go directly to the ground. Thankfully, our operator would be sitting inside the cab here if our crane here were to come in contact with electrical power. The crane became energized. energy flowed from the load line down the boom, into the crane, down the outriggers, into the ground, the operator would probably be fine. He probably could sit there in that cab for quite a while. No issues. In the event, though, that somebody comes walking up to the truck, and they have what's called step potential. Step potential is the difference of electrical current flowing through the ground. So as you approach the crane, one foot may have one level of voltage. The other foot may have a different level of voltage. Well, voltage is going to follow the path of least resistance. So as you pick up that rear foot, now you have all of the potential in one foot. When that next foot comes in contact with the ground, that's going to be the next outlet, therefore creating electrical contact. So if the event that your crane does come in contact with electrical hazards, your crane becomes energized, you go walk up to the operator, ask what's going on, and you feel your toes start to tingle, stop what you're doing, and just simply do the moonwalk backwards. We usually teach the bunny hop. The problem with the bunny hop is over time, you eventually start favoring one foot or the other and start making contact unequally. So we want to make sure we can do the bunny hop if you can only land perfectly flat every single time, which isn't reality. Also, you have the potential of while you're bunny hopping, you could trip, you could fall, you could stumble, and then now your hand's coming down making contact. When that hand makes contact, you have the same problem as the 2 feet. So it's best just to do the moonwalk, shuffle your feet backwards until you can no longer feel the tingling in your toes. So minimum approach distance. It's mad. What is our minimum approach distance for crane work? Per the Z133, 10 feet is as close as you can get doing crane work to electrical hazards. That's primaries, communication wires, so forth. 10 feet. Now, I understand in the Z133, we have different tables for qualified line clearance, qualified incidental line clearance, and non-qualified. But when it comes to trains, 10 feet is as close as we can operate per Z133. Now, I'm sure there's people out there who have operated closer than 10 feet. It's your life. You choose to do what you wish. But as far as the Z133 is concerned and OSHA is concerned, 10 feet is the rule that we operate with. In the construction industry, it's 50 feet. So we're actually operating closer than the construction industry is allowed to operate. So with the 3 types of clearance we talked about, you have non-qualified, or not qualified, sorry, qualified incidental, and qualified line clearance. The only difference between these 3 is the training you have and who you're working for. So in the non-qualified or not qualified section, you have no formal training in electrical hazard awareness. You have not had CPR first aid, and you've not had aerial rescue training. Once you get those 3 aspects, you now have the training component of being a qualified line clearance arborist or qualified incidental line clearance arborist. The difference now is who you work for. So if I'm running this crane, and today we're doing a residential tree care job, removing a large tree, and there's power lines on the customer's property, and we're working directly for the customer. I am a qualified incidental line clearance arborist because I'm working for the consumer. The exact same job, though, and we're being contracted by the power company to come in, who is the owner or the provider of the electricity. Now we are a qualified line clearance arborist. Exact same training, exact same qualifications. The difference is who we're working for. But that doesn't change the fact that with our crane, we can still only operate 10 feet. The 3 tables that you see here are just how we're allowed to operate. We're going to skip over all that and go right into safe lifting and the load charts. So that's it for section 2. Section 2 is one of the smallest sections in the book. It is 2 pages. Real easy to do, no big deal. So before we move on to chapter 3, which is safe lifting and dealing in load charts and all that, is there any questions of electrical hazards?
I do have a question here from Stephen Pearson. Just asked, is the approach distance the same even if you have lines locked out and booted?
So if a line is locked out and booted, I'm not quite sure what you mean by booted. I assume what you're meaning, Stephen, is the lines have got protectors on them, so they're guarded wires. A guarded wire is still considered energized. So the only way you'd be able to operate closer than 10 feet is if the lines have been de-energized, disconnected, and grounded. So both fuses on both ends of the transformer have been pulled from the span. then the wire has actually been grounded to the ground, and now that system is de-energized. Once your system has been de-energized, you can operate as close as possible to that system because it is a de-energized system. But if you're not de-energizing the system, 10 feet is still the rule.
Gotcha.
See here. I'm scrolling through questions real quick.
Okay, you can see them too.
I can.
Nicorea apparently lives somewhere where they're doing construction on property that's only 40 feet wide.
Okay.
Apparently that's what LA looks like.
That's LA, yeah, pretty much.
Property there. If the crane becomes energized, is the operator safe if he stays on the truck? You mentioned that a little bit. Do you want to talk about that for a minute?
In theory, the operator would be safe, in theory. If they are on the truck itself, the truck were to become energized, and they stayed perfectly still, didn't touch anything, didn't move around anything, they are now part of the energized system. In theory, they would be okay. If they tried to get off the truck and make contact with the ground, then obviously the path of travel for electricity would be through them. They would not be okay. If they had a heart condition, they could not be okay. If they had an internal pacemaker or defibrillator, they could have issues with that from electrical current. But in theory, if the crane became under contact with electrical power and became energized and the operator stayed put, they could be okay. I'm not going to say 100% they would be because there's so many variables involved there, but they could be in theory okay. And the best thing would probably be to do is if you're not hurt, just stay where you're at. Trying to climb off the crane to get down actually creates a higher hazard than staying put.
Gotcha. All right. I think we can go on to the next section.
All right. So we've gotten through the easy stuff, and now we're going to get into the more of the meat and potatoes of this. We're going to talk about safe lifting. Safe lifting, we're going to look at load charts, load radius, and how we can calculate the weight of wood. So the first thing we're going to talk about is load charts. In a load chart, like the one here on this page, there's a very distinct dark black line on this load chart that goes straight through it. What that's saying is if you exceed the numbers above that black line, you will fail your crane, meaning you will break it. If you exceed those numbers below the black line, you flip the crane. Cranes are built on two principles, strength and stability. Therefore, our chart is built the same way. We have stability factors, which are above the black line. Structural factors, which are above the black line, and stability factors, which are below the black line. Some different load charts, different manufacturers will shade them one way or the other. Most of them, though, have just a distinct black line. This one does black line and shading in this picture here inside the manual. And what that says is, if this is our crane set up here and we're operating at this radius, if we exceed the load rated capacity at this radius and we're above the black line, we will fail the boom. Meaning the boom will break, it'll crease, it'll fall, it'll collapse. The crane will not flip over. However, if we exceed the weight and we're operating at a radius that's below the black line, then our crane has the potential to flip. Because our lever point has changed, now we are not failing the boom, we're just flipping the crane. So those are the two differences in load charts and how we deal with stability versus structural. We also have to look at the radius that we're operating at. All cranes come with a radius chart as well. This radius tells you at what boom length and at what boom angle, what radius you could operate at. We want to stay within 75% of our rated capacity when doing tree work. Some places will tell you 80%. I personally teach 75%. That's my personal choice. That's not an industry standard. Reason being is it's an easier math to do as an operator to do 3/4 of my capacity than it is to try to figure 80% of my capacity. I'm not that good with math sometimes. The cranes I've run haven't been the really, really fancy cranes where I can plug everything into a calculator and has the nice LMIs. They've been more the boom truck style cranes that have more basic load in moment indicators that don't allow me that ability to know that. So I've always operated with 75% of my capacity is where I'm gonna do tree work at. That gives me a buffer zone. That gives me the ability that if we have a piece that may be waterlogged, it may have some factors we didn't figure into our wood weight, and we think it's going to be 2,000 pounds, it ends up being 2,200 pounds, I'm still within capacity. But if I'm operating at 80% of my chart, and then we have something like that happen, I have a higher chance of exceeding my chart's capabilities, and thus either breaking my crane or flipping the crane. Greatest thing about a crane is I don't have to pick the piece up. The crane's going to do that work. So why chance it? Why push the envelope and do bigger and bigger pieces when we can just do one more pick? We have a lot of cranes that go over every year in tree care. A lot of them go over because of this reason. They try to go big with every pick, and they end up exceeding the load charts and flipping or breaking their cranes. So how do we figure out our weights? Ironically enough, way back when, Leonardo da Vinci had a theory. It was called symmetry in nature. What that theory stated is that a daughter branches cannot exceed that of the parent branch. So if my branch goes up and it's 6 inches around, and then it has a branch union that goes to 2 other branches, those 2 other branches' diameter cannot exceed that of the main parent material. If they did, the tree would fall apart. It wouldn't be structurally able to support itself. So there's some math that comes involved in this. For those people who enjoy the math, you can go out and try it out. I've done it at a college program I was a part of for a little while, and the math worked out for us. When you add up the diameters above a branch, they end up equaling that of the main branch. Now, obviously, where the branch union is at specifically will be larger because you have 2 branches coming into one. That area will be larger. But take your measurement 6, 8 inches below the union and then 6, 8 inches above the union and see if it works out for you. My experience has been that it works out perfectly every time. So in this picture here in this image on the right-hand side, if you can imagine, that main stem comes up to the very first union. What this theory states is that that first union cannot exceed those 2 branches. Diameters cannot exceed that of the base. And then we continue to work that out the whole way of the branch of the tree. So a lot of times people are asking me how to measure weights and how to calculate weights. The easiest way is to figure out what a 10-foot section at a certain diameter is going to weigh. If you know that you're dealing on a 12-inch or 20-inch round tree, and you know that a 10-foot section weighs X amount on a 20-inch round piece. Well, if the union goes up and there's a union there, that 2 pieces can't exceed that of the 20 inches. So all I have to do is measure out 10 more feet so I can do a 20-foot piece. It can't exceed that. So what this is getting at is that you can do this all the way out to the farthest ends of the tips of the branches. If you were to take branches and if you could collapse them all together into one, taking out any void spaces, that diameter cannot exceed that of the parent branch it comes from. So this is able to do this where you can figure the math out pretty quickly, like the picture here on the right, all the way out to the tips. Adding all those diameters up cannot exceed that from where we're making the cut on that pick. Otherwise, the tree would not be structurally sound. It would fall apart. So it's a little bit hard concept sometimes for people to understand. I would challenge you on your work days to start looking at that. Start just doing some field testing. Make sure you're using the fact that combining 2 together does create voids because it's 2 round objects coming together. It creates a void. So you actually have to do the math principles of it, get the diameters and the radius and all that. But once you've done the math on it, you'll find that they equal the same amounts. And it's a very easy way to calculate weights. Because now I don't have to know what 10 feet at 6 inches weighs, and then 5 more feet at 3 inches, and 5 more feet at 3 inches, and then what that 5 more feet at 2 inches and 2 inches equals. I don't have to know that. All I have to know is that if I'm cutting a 6-inch stem, however long that piece is going to be, cannot exceed that of the 6 inches. Now, obviously, there's foliage weight that goes involved and water weight as well. We're only talking about how to calculate for the diameter right now. So before I move on from that, I want to make sure everybody understands that. Again, it's kind of a hard principle sometimes to grasp. So let's see if we have any questions about that and kind of make sure we've got that covered really well.
I don't think we have any questions about that. Stephen Connolly does bring up that union wood and compartment wood is exponentially heavier than a single log of the same diameter.
Correct. And that's where I said, Stephen, you're looking at the unions. Where the unions come together, it's going to be the heavier pieces. You have two pieces coming together, and you have to figure those in. The only way I have learned to do that is just off experience. I've tried taking the measurements of unions and applying a green log weight chart. It just doesn't work. I had to kind of just use experience on that. But the principles as far as the main stem pieces, that has held true for me so far. Have you had the same thought process, Stephen? Trying to read through the comments real quick here.
They're on a little bit of a delay from us talking right now. I do have somebody wanted to see that formula. I don't know if they're going to try to do it, but there it is.
Yeah, you can try to do it. Yeah, knock yourself out. I'm not that good of math to figure that out. I just use this image here that, as the branch works its way up the tree, you're not going to exceed that. If you have your book on page 18, there's some really good explanation of this and working in that formula and all that. Some really more in-depth information into this theory, and you can apply that. I just think it's interesting for the fact that Leonardo da Vinci thought about this years ago in relation to nature and how nature supports itself. So I think that's kind of a fun little fact. Just I geek out on those kind of things sometimes.
I think you did a good job of explaining that. I think we're ready to go on to the next part.
All right.
If you are.
Wonderful. Yep. 1 second. All right. So we're going to talk about some wind. That's our next part. Dealing in wind. Every manufacturer has different recommendations for how much wind you can operate in and how much wind you can't operate in. Look at your manufacturer recommendation. Usually bigger cranes have got anemometers at the very tip, which tells you how much wind the tip of the boom is receiving versus at ground level. So follow the manufacturer recommendation. Just remember that when you have a load hanging off the end of your load line, that's acting as a giant sail or a kite. So any wind you're going to be getting is going to be much more highly felt by the crane because you have this big catch for wind here. And that's how you easily can get some swing going, which creates side loading on your boom. Crane booms are designed by physics to operate in the load under position, not load beside position. So when you're starting to pull your load from one side to the other, you can have a lot of failures pretty quickly there because that's not how the way the crane's physics and engineering work. So that's kind of the wind stuff. We're going to hop onto soils real quick and talk about some soils, and then we're going to come back to soils in more depth here in a minute. So some quick numbers to remember, if you can commit them to memory or take a picture of it, is load-bearing capacities for soil. The very first one is undisturbed soil and lawns. Undisturbed soils and lawns operates at 22 psi. Asphalt's 29 psi. Clay and silt is 43 psi. Mixed granular is 51 psi. Firm compacted gravel is more of like your construction type sites. It's more your engineered gravel sites for setup. That's 58 to 109 psi, depending on how much aggregate they do or don't have inside the mixture. And then concrete is 1,000 psi on an 8-inch depth pour. The top picture on the right-hand side I took while I was in Knoxville, Tennessee one year. That's actually from the off-weight side of a link belt 60-ton crane. They were picking off the driver's side of the crane. And this outrigger's on the passenger side of the crane. They put the outrigger straight down onto the asphalt and had about 1 inch of depression in that asphalt. So even though they weren't picking weight over that side, just the weight of the machine itself created about 1 inch of compression in the asphalt, which is enough to put the crane out of level if they're not careful. Big thing here is just understanding how much PSI your crane's distributing to the soils, and we're going to do the math on that in the next section, and how we can overcome some of these soil setups. So also in safe lifting, we want to talk about dynamic loading. Dynamic loading is when you accelerate a piece too quickly or stop a piece too suddenly. What thus happens is if I move my crane too quickly and drop my piece as such, the effective weight that my crane is actually feeling is much heavier than that of the actual weight. And that's where a lot of times we'll see these booms crease, like in this picture here, is because our operators are either A, hoisting too quickly or stopping too suddenly. So if I have a 500-pound load on here and I try to snatch it really fast, the crane's going to feel much more weight than first trying to move that weight. If I pick it nice and slow, the crane will feel the actual weight to it. The same is the reverse of that. If I have a 500-pound load on here and I'm slowly lowering it and I just stop and shock load my crane, the crane will feel that this piece weighs much more than 500 pounds. All right. This is very important in tree work because a lot of times we're cutting, rigging things from a tree. And if we're not making sure that our loads are very stable, all of our picks are very stable, you run a much greater risk of dynamically loading the crane and how the piece comes under tension of the wire. I've sadly seen some people doing crane work that have actually used felling notches and have felled tree stems into the load line and shocked the whole crane. You hear the wire slapping the top of the boom, and very bad things are occurring. This dynamic loading the crane. What you're having there is that effective weight that's being felt is much higher than the actual weight, and you'll exceed your capacities in your chart, creating a structural failure or a tipping and a stability failure. All right, we're gonna talk about setup real quick. So now we talked about the PSI. We know how much we're good for on PSI of our different soils, be it lawn, be it aggregate, be it concrete. But now how do we get over? How do we correct those problems? All right. These next photos, I was given permission to share. Some people have probably seen these photos. They just recently were on the intranet, on the Facebook, in relation to a crane that went over in New Jersey. So just going to share these. So don't anybody harass me for them. All right. But what happened here is the crane was set up operating in a backyard situation. The outrigger was put roughly about 3 to 4 feet from the foundation, set up on top of mulch. There obviously something occurred. The outrigger sunk. The crane ended up tipping, going over. So there may have been a void space. There may have been some compaction issues. And if you'll just keep clicking through those photos real quick there, Kale, get to 27 for me. All right. You can see how much the outrigger sunk in. This is not an A-frame outrigger. This is what's called an out and down outrigger, which is the exact similar to what we have here, where the outrigger comes out from the crane and then goes down. However, in that picture, it makes it look like it's an A-frame outrigger where it comes at a 45-degree angle. That's how much failure occurred in the soil due to a void space, due to a backfill, and some other things. Setting up that close to the foundation, there are some setback issues there that we had to look at to try to correct those things. Number one way we correct for our cranes and is dealing with PSI is in our dunnage. So not our tonnage. Our tonnage is what the crane can pick. Our dunnage is what we put down underneath our outriggers to displace weight to our soils or to gain height in order to level our crane. You achieve the same thing from both operations, but it's two different purposes. As you can see here, the crane I have set up here, where I'm using some cardboard as my dunnage, roughly 2-inch by 2-inch pieces. And I've got them stacked 3 high in order to get enough level to get all my tires off the ground and get my crane level. And I was able to level the crane just by doing that. Unfortunately, it's not always that easy. Most of the time we're using actual wood material, wood or synthetic material. There's been a lot of discussion over the years in regards to box style cribbing versus flat cribbing. Both of those shown in this next photo. The one on the left was a 3x3 box cribbing. That 3x3 is like building Lincoln logs. You're literally stacking 3 pieces on top of each other. All right. Each one of those points of contact has a PSI rating. All right. This is a Douglas fir. Douglas fir has roughly a 500 PSI shear strength. So when we figure that math out on a 3x3, meaning 3 pieces, put it on top of 3 pieces, we're at 6,000 pounds per contact point, 9 contact points. And that cribbing and that style, that box style cribbing, is good for 5,400 PSI before failure. Now, if we did the exact same size cribbing, which is 4-inch by 4-inch wood, and we did a 5x5, meaning 5 pieces on top of 5 pieces being perfectly level and in full contact, we're at 150 PSI. Now, that's not 150,000 PSI. That's not 150,000 PSI of soil displacement. That's shear strength of the wood before the wood fails. So if we have to gain height, it is perfectly acceptable to use the box cribbing style cribbing to gain height. But I highly recommend that your first level and your top level be solid pieces slammed all together. That provides the most stable footing. And then in the middle between those two solid pieces can be the box style cribbing, be it 3x3, 4x4, or whatever you need to do. But just make sure that the amount of contact points equals the amount of weight our crane weighs and how much it's going to be lifting. So therefore, we don't have a shear failure in the wood. All right, so the next thing we're going to look at is how much PSI does our crane displace to the soil. So now we've talked about how much PSI our wood can handle, but now we're trying to make sure we're dealing in the correct PSI to our soil. As we talked about earlier, we're operating, say, a lawn, or say we're operating an asphalt, which is 29 PSI. We want to make sure that the weight of our crane, plus the heaviest pick we're going to do, if we're over top of one outrigger, so if we're over the top of this corner outrigger here, can displace enough ground pressure to not fail the soil that we're operating on. So in order to do that, what you need to do is you take the weight of your crane, the weight of your crane divided by the number of outriggers, and then whatever your heaviest weight's going to be to do the point loading. So if our heaviest load is going to be 10,000 pounds, for instance, we figure out the weight of our crane divided by our number of outriggers. We add 10,000 pounds because that's the max weight this one outrigger will feel if we do what's called point loading, which is where that one load is directly in line with that one outrigger, is point loading. From there, we have to look at how much we're getting, how much pounds are per outrigger. Then we figure out the square inches of our outrigger support, meaning how much material we're putting on the ground here. If we're using a 2 foot by 2 foot size piece of wood, for instance, or a mat, or cribbing, wood cribbing that comes in 2 foot by 2 foot length, you're at 576 square inches. So now all you do is take the max load that one outrigger is going to feel, divided by the square inches of outrigger displacement, gives you how much PSI is being translated to the soil. So hypothetically speaking, on this crane here, if this crane weighed 370 pounds, and our heaviest pick of the day is going to be 10,000 pounds, that gives us a total weight of 89,370. We then divide that by the 4 outriggers and gives us an individual point load of 22,342.5 pounds. 2 foot by 2 foot outrigger pads gets us 570 square inches, gets us down to 38.78 PSI, which is fine if we're operating on a clay and silt soil. But if we were setting this crane up on asphalt or a lawn, we would actually fail the soil at that displacement. We would need more wider dunnage laid down in order to get a lesser displacement to get the PSI to a better rating for that soil. So that's just a real easy way to figure out how much you're displacing to the soil and how to figure out to lay down the right cribbing or the right style in order to get the right displacement for that thing. As you can see in the next photo, there's different ways to do that by using solid matting style, which is wood that is bolted all together to create one layer. You've got all tour mats or the those big yard armor mats now. You can do it that way, or you can just use regular 4x4, 4x6, 6x6, 6x8, 8x8 timbers. Works as well. In this photo also, you see that there is what's called a leveling block in the middle photo. What that is, if you have an uneven area, you can either dig it out or you can put what's called a leveling block in. It's kind of hard to see from the pine straw in this picture, but there's actually another leveling block, another towing block further under there that in the event that those materials start to collapse, it'll actually engage that other block underneath there and prevent a failure straight down. But that's perfectly acceptable. You can see the stack cribbing in this photo here in order to gain height, in order to get this crane level, had to get pretty high. The biggest thing is we have to understand that when we have displacement, that displacement is not uniform. It's like dropping a pebble into a stream or into a pond. When you drop that pebble into a pond, those rings go out and dissipate. The same thing's occurring from the weight of our crane. As this load is being loaded here, the weight's being translated to our outrigger, and that weight is radiating out from our outrigger in a uniform fashion. As that radiates out and comes in contact with an object, it's going to apply pressure differently as it comes in contact with that object. Thus, how we get to setback. So in the photo we looked at of the crane that went over earlier on in this module, they were about 2 to 3 feet from the foundation wall. Now, in talking to the people who were on site, they didn't have any failure of the actual foundation wall. So they didn't collapse in the basement. They didn't collapse in the crawl space. Most likely what occurred, there was some void due to that being new construction and the soil not being compacted well enough around the foundation. Found a void and collapsed the void. When we know setback, there's 2 different principles used with setback. If you know the depth of the object in the ground that you're setting up next to, you can be 1 times the depth away from that with your outrigger. If you don't know the depth, though, it's 4 times whatever the widest part of your dunnage is. So on this crane here, if we're using the 2-inch by 2-inch cribbing I have set up, we just do that times 4, tells me how far I could be from an underground object, be it a terrace wall, an excavation, a vault, a foundation, any of those things that go underground. Because as you can see in this photo, or this image, as things go outward, they displace energy. As they displace energy uniformly, things come into contact here and then a little bit off, and that pushes against the wall. That's why setback is so key and so important. So that's the end of that module, module 3. We're going to take a quick little break. I'm sorry, module 4. We're going to take a quick little break before we get into slings and connections. I'm going to stretch my legs for a second, and we'll be right back.
Very first thing up top is my PPE. I keep my helmet in here in a nice clogger buff. Keep my helmet right where I need it at all times. After that, pop open my interior compartment and we'll take a look. First thing on top is my saddle. Keep my tree motion, has my lanyard on here, blood stopper pack kit, akimbo, and everything else that I could possibly need for a day in the trees. After that, I have my chainsaw lanyard, my socket neoscinder, a pulley saver for when I'm climbing double rope systems, handsaw, 1 cube, 2 throw line cubes, a zigzag with a chicane, and then my climbing line in the big bag. And inside my climbing line, I've got a Sterling SRT line with a zigzag and chicane on that as well. Notch, wedges where I'm in the tree, extra foot loops for my socket, my med kit, and because I'm allergic to bees, I carry my EpiPens. In the very front of my notch bag, I've got a collection of hardware, some thimble, Prosix, a notch throw bag, some extra cordage, and a quickie tool for when I'm using my rope runner. This is my notch bag and all the gear I keep.
Well, there's a lot of different things that go into the estimation of a tree.
A wise man once told me never assess a tree from the road. Always walk up on the tree, take a look around 360 around the tree. You never know what the backside of a tree holds. You know, it might be rotten and decayed, and that can totally change how you're going to go about removing that tree and you know, what kind of equipment's going to be needed to do that.
I bit a tree by breaking it down bit by bit to the smallest parts of the job.
We look at it from an hourly standpoint, how the salesmen that we have bid a job on how long they think the job's going to take, and they break it down like that. And then I get a work order that gives me an idea of how much time we're going to be spending on the property.
My customers like it when I can break it down for them and itemize it to show them where their money is going, rather than just saying, oh, I think that tree's about $1,500. Well, why? Well, here's why. my time, my guy's time, my materials that I'm moving out for you, and you have 4 comm drops and a hotline right next to the tree. That's how I reached that conclusion.
Also, a big part of it is obstacles, in the way of hazards. Are you removing a monster oak tree, overhanging umpteen million service drops, primaries, pole-to-pole, houses, garages, you know what I'm saying? Those are all big factors. But I think the biggest one is knowing the capabilities of your crew.
Who do you have there? What skill set is there? What is their speed? How well versed are they in being able to develop a complex rigging situation with no guidance?
I usually gauge the neighborhood that I'm bidding in. I gauge how far it is going to be to have the groundsman drag it out. How much equipment am I going to need? Do I need loaders and things like that, or is this something I can do, by hand? How many guys? How long will it take? And of course, then the obvious things: how big is the tree?
It's a large orchestration of many different moving parts.
I always say there are about 300 different variables that go into the estimation of a tree. For me personally, I know the set rate that I want to get per man hour, and then I usually gauge based upon that time it's going to take and everything else I'm going to need, try to come up with a number like that. Just like everything else in life, you got to make the best out of a bad situation.
That's something that each person, I think, really has to find inside themselves, as far as having that mental fortitude to be like, it's gonna end eventually. And one of the best old-timer lines that I ever heard is he looks over at me as I look like I'm about to die in the heat and said, "Nobody ever drowned in sweat, boy."
Money. That's it. I got to pay the bills. You're gonna have days that are awesome and days that suck, but at the end of the day, you got bills to pay. So that's what gets me through a tough day.
Leaving an unsafe site is something I can't put up with. I just will not leave a risky tree off the ground, or trip hazards, or even if the people that are coming to clean it up, if I consider it beyond their capability to bring the rest of the tree flat to the ground, I will stay until it's done. If it's raining, if it's hot, if there's bees, my motivation is safety for the people that come after me.
Having good employees around me that are willing to just power through with a positive attitude as well. If the team can come together and go, listen, yeah, we know today's crap. It's going to be an awful day, but we're going to get through it together. A positive attitude for the whole team really goes a long way. And then we can have fun even though we're in a terrible job, either whether it be covered in poison ivy or working in a down floor. And that's sort of what has always gotten me through those days. The people around me.
I thrive in that atmosphere because I spend so much time driving. The opportunity to get soaking wet, freezing cold, and filthy dirty is a welcome thing for me. So I'm digging in and I'm getting my CPs full of mud and dirt and filth and cold and just gutting it out.
I knew when I got into this I would be exposed to the elements, and part of it is accepting it, and you got to have thick skin to be an arborist anyway, so that helps.
What keeps me going is finally getting into my car at the end of the day and saying, yeah, we finished it up. Everybody's little fingers and toes are intact. Finishing up safely is what the end goal is.
Hi, I'm Cale Royer, head party animal at TreeStuff.com. I'm here to make sure that everyone knows about our Tree Stuff Party program. Each month, volunteer arborists from different regions host free recreational climbing events powered by TreeStuff.com, giving local arborists a chance to meet, hang out, climb, and try out some cool new gear in the trees. Every Tree Stuff party is 100% free, so there's no reason to not bring your family, friends, coworkers, and acquaintances. Check our Facebook events page to learn about upcoming Tree Stuff parties, and sign up to be notified when there's a new Tree Stuff party in your neck of the woods at treestuff.com/parties. It's all about seeing friends, making new friends, and having fun in the trees. I hope you can make it to a party soon.
All right. Welcome back. Hope you guys enjoyed that short little commercial break. Gave me a chance to stretch my legs and kind of get things reset for the next part of this thing. I saw there were some great comments in regards to how sexy Derek Martin is. I must agree. He is a sexy, sexy beast. In regards to helmet stickers, yes, I have stickers on my helmet. They don't preclude me from inspecting my helmet, so therefore I have them on there, and Cass told me I'm fine as long as they don't preclude me inspecting my helmet. So I don't believe in covering your helmet in stickers, but yes, I do have 2 stickers on my helmet for those who caught that in the video. So thank you for pointing that out, because Lord knows if you post anything online, we're going to just tear it apart in any way we can. So thank you for that. All right. Next one to chapter 5. So we're halfway through the TCIA Tree Care Academy Crane Operations Specialist book. We're in chapter 5 or module 5, which is slings, fittings, and connections. The other book we have here is the Crane BMP. Yes, Stephen Connolly, there is a math error inside this book that got translated wrong. Good catch on that as well. You say you're not good at math, but good job on catching the math error there. So when we're talking about slings and connections, what we're talking about is the wire rope, chains, nylon, rope slings, all the different things that are going to hang off of our block to our load. That's what we're talking about when we're talking about slings. They could be a wire rope sling. They could be a chain sling. They could be nylon slings, rope slings, so forth. We're talking about connections. We're talking about the hooks and shackles that we're actually utilizing to either bind our load to our sling, or in some cases, the sling to our ball or our block up here. So we were both using connections in both aspects. Just some things that know there. So we're talking about slings. The very first thing is we have to understand the OSHA requirements for slings. All slings are required by OSHA to have an ID tag on them. So you can't just go make a sling from home from old bull rope you have lying around that doesn't have an OSHA rated tag on it. It has to have a tag, and there's 4 things that have to be present on all tags in regards to crane work. The very first thing is you have to have the capacities for use. Those capacities for use have to come in 3 different configurations. A vertical, which would be if we had this sling here. Thank you, TreeStuff, for the micro whoopee here. So straight line pull, that's a vertical configuration. If we were to have a shackle here and a shackle here to say an eye bolt and a piece of concrete, that's a vertical pull. All right. Then you have a choker. Choker is exactly that. If we choke the piece off to a piece of material, that is the rated capacity for the sling as a choker. And then we have basket configuration. Basket is making exactly that. We are taking the load and hooking it back up to the block and having 2 parts of sling hang down with no joining in the middle, and the piece just sits there. Obviously, some very big inherent dangers in using this kind of configuration in tree work, as this piece has nothing to hold it in place. You can imagine if that was a log, that could go through a people's house, deck, person pretty easily. So the majority of what we use our slings for is in the choker configuration. Either it be using a regular shackle to choke something back off, using a soft shackle, using a knot of some form, be it a running bowline, a closed clove, something like that. Some way in which you're creating a bend on the rope at one position, one termination, that's considered a choker. The next thing you have to have is you have to have the material being utilized. So we have to know the kind of material that the sling is made of. Is it going to be a nylon sling, a chain sling, what kind of chains it rated for, and those so forth. Next is the code and stock number. So you have to have a code or stock number for every sling. That is a unique identifier. And then you have to have the manufacturer ID. All right. So if it's a manufacturer ID, if it's a Lift X or if it's a Teufelberger product, I run the Teufelberger crane slings. Those are slings I enjoy and I like. That's the manufacturer ID. I see Nick's got a question real quick. Do you have to tag it with 3 ratings if it's a dead eye sling that wouldn't be used in a basket configuration? Yes, Nick. You still have to have the 3 different configurations and the rated capacities, even if you're not going to utilize it in that fashion, per the OSHA regulation. So as silly as that might sound, and I don't know, Cal OSHA may be slightly different because it's California and everything's different. So check with Cal OSHA on that to be specific to your state. But I know most states require it no matter what. You still have to have all 3 configurations identified and their capacities, even if you're only going to be utilizing it in one configuration. All right. Next, we're going to look at our sling angles. All right. Where our sling angles come into play is when we're having multiple slings on and how that changes the capacity. All right. So if we had this sling here, and we're just going to kind of use a little bit of our imagination here. And it was through our crane this way. Let me make another termination here. The angle that we're creating here, this is the sling angle we're referring to. All right. The closer this gets together, the stronger capacity our sling has. The further apart these get, the weaker our capacity has. So if this sling is coming up directly at a 90-degree angle, so if we get it to the point where we're at a 90-degree angle like this, and say this piece weighs 1,000 pounds here, each leg of this sling is only holding 500 pounds. But as we move further away, that changes. Once we get to a 45-degree angle, you have a 1,000-pound piece. This leg has 707 pounds. This leg has 707 pounds. And there is 500 pounds actually of pressure being applied this way on this piece. So this piece is actually being compressed with 500 pounds of pressure this way. As you continue to work on up and shorten your sling, so come back here. If I were to say bind this thing somewhere around here, it's kind of hard to see, and our sling gets really flat angles, now we're having more pressure applied at the piece and our capacity is diminished even further. The easiest way to figure this out is take the height of attachment to the ball, to your piece, the distance from here to here, divided by the length of the sling from here to here, times its rated capacity. And that will tell you the lifting capacity for that angle at that sling. Now, for most of our stuff we do, we go back to this kind of configuration the majority of the time. We're operating straight down, 90-degree angle, and we just simply have to use the capacity of a choker. But in the event that we were using this as a choker, as such, like I showed you a minute ago, we would take the height divided by the length times the choker capacity for this sling. Would tell us how much this lifting capacity for this sling would be on this piece. This is one of our failure points in doing crane work. We know the weight of our crane can hold. We know how much the piece is going to hold. We also need to know what our rigging can hold. Right. Next, we're going to look at the connections. So the shackles we use. There's 3 different types of shackles shown here. There is the screw lock shackle where it actually has a pin in it that you can screw shut. So it actually has a bolt with a pin on it. You have the actual screw shackle, the old style that just screws into itself. And then you have a quick turn clevis or quick turn shackle. All 3 are work very well in tree care. There are some inherent problems with each one. So just make sure you understand how those work and apply differently. The big thing here with shackles is you never want to exceed 120-degree angles on the shackle in the direction of which the slings are being pulled. On the Crosby shackles, they put indicators on the Crosby shackles for the sling to not exceed that. So you're not pulling the shackle the wrong direction that it's not rated for. All right. Just a little graphic here to show kind of some problems with how slings can be loaded into the hook differently, with the hook bunching up, with the straps being laid over themselves and so forth. Real simple, easy stuff. Next, we're going to look at our actual sling types. So here we have a dead-eye sling with balancer pieces on it. You've got endless round slings. And then you have a choked off sling, endless round sling that's sloped off with a screw lock shackle. In this image here, the screw part is on the non-moving section of the endless round sling. It's really where we want it. If you were to put that on the other side, you run the potential of that screw being turned and backed out of the shackle, or being put so tight when it gets to the ground, your ground crew has a hard time getting it open. Using a scrunch like that to get it open isn't ideal. So just make sure that it's in the non-moving part of the round sling when it's applied to the tree. All right. Also, we have soft shackles. soft shackle is a rope product that has a whoopee style motion on it on a round piece, and then has a knot on the other side. And I'm going to try to do my best here to kind of show what that would look like. All right. So if I slide this all the way down, I've got my end here. All right. If I were to pass this through here, and this was my knotted end, right? And then I tighten this down, this knot can't pass through this because all this has got friction on it here. So this was a knot. Say it's not a loop, it's a knot. That soft shackle now can't pass through here. That creates the soft shackle. They're a great tool. They actually come from the towing and recovery industry. Been around a long time. Been used a long time in the towing industry. Have a huge use for us in tree care. The biggest downside is over time, they do have a tendency to stretch. They do have a tendency to wear out. So you have to police that and just make sure that they're staying tight and being utilized correctly by the climbers and ground crew and being treated correctly because it is a soft product. The advantage there is it is a soft product. If you were to drop it from the top of a tree, you don't have to worry about it damaging somebody or damaging some property as you would with a metal shackle. So there's a nice part there. As a climber, you could carry multiple of these on your saddle. They don't weigh a whole lot. It just gives you more options there for quick attachments. All right, last we're going to talk about the climber connection. We're going to talk about how the climber connects to the crane. What you have here is the Z133 requirement, which is the Z133 5.7.11 and 5.7.11.2.2, is in regards to the climber being tied in twice while hoisting. So 2 tie-in points. You have to have one above the block and then a second tie-in point through the throat of the hook. This is only required when hoisting. So while you are being hoisted from the ground level up into the canopy, once you are into the canopy, you are now what's considered in work positioning. You are no longer in the hoisting fashion. You are in work positioning. Therefore, you do not have to have the 2 points of attachment. It is only for in hoisting because we feel that the highest chance of having an injury or an incident is in that hoist there that is occurring. We had a fatality in New England last year where a climber's bridge failed while in the hoist position, was only tied in once, didn't have that second tie-in, and therefore ended up in a fatality. So just make sure when you're getting lifted off the ground, you've got your primary tie-in above the ball or above the hook, and then you have your secondary tie-in through the shackle, or I mean not through the shackle, I'm sorry, through the block. And what I do is I use my lanyard, run my lanyard through the block and back on my saddle, and that's my second attachment point. Really easy, really simple, nothing too complex there. There's lots of different ways to attach a climber to a load line. There's the kit that TreeStuff sells. There is the ability to put a shackle on the load line to a ring and ring. You could girth a ring and ring. You could build what I had Reed Wortley built for me in this picture here, which is 2 opposing gate captive eye steel carabiners with epicord lock stitched together to 2 steel rings at the bottom. It's a product that Reed Wortley made for me, and it's a great product. I love it. It allows me to just clip it right on my load line, and I'm good to go. So there's different ways to do it. Again, not a lot of right ways, but there are some wrong ways. You always want to make sure that you don't have any soft product in contact with your load line. Load lines tend to have a lot of burrs in them, a lot of metal, a lot of grease. So you really wouldn't want a soft product in direct contact with your load line. There's potential there it could get cut and could have a fall, something that way. Just some different options there. Any questions in regards to section 5, which is slings, connections, and etc.?
Yes, I've got. We've got a few people talking about how they feel about soft shackles.
Wonderful.
What was that?
Wonderful. Opinions are great.
Okay. What is your opinion on them?
Soft shackles, in my opinion, have the ability to work very well for our industry if used correctly and monitored regularly. Again, they've been utilized in the towing and recovery industry for a long time. You're not using the soft shackle for the primary lifting. You're using it for the binding of the lifting strap back to itself. Again, it's a great product that when used correctly and when inspected regularly has a long service life, but there is some inherent problems with them. They do stretch, they do wear down. So there are some things you have to watch for, but like any piece of tool we use, if you don't inspect it regularly and expect it to work every time, you may end up with a problem. So you should be inspecting all your gear constantly, and the soft shackle is no different. It's just another option. I'm not saying a soft shackle is better than a locking shackle or vice versa. Just another tool in the toolbox to utilize, and a tool that can be utilized correctly when you know what you're doing and use it properly.
Okay, I've got something here from Stephen Pearson. He's asking about slang term, a possible slang term, talking about the secret handshake, a setup for hoisting stem wood, especially really nasty pieces with multiple unions. I'm just gonna.
Yep. So this.
Yeah, I don't know what that means.
So the secret handshake, it's gonna be hard to do with this sling here, but I've got some other slings in the back of my crane here. Hold on, I can get to. The nice thing about this wonderful model, it actually has storage compartments for all my slings. So let me get my other slings out here. My custom-made throw line slings. High quality material.
From Rope Logic, of course.
Yes, I do believe they are. They are notch throw line slings. Yes, sure. You can use that in product placement. So we're going to tie these up real quick. Kind of get them out of the way because we only need 2 of them to do this. All right. So in the secret handshake, what you're doing is you have 2 slings hanging down. Let me drop my load line a little bit here. You are taking one sling around the piece and tying a running bowline or some type of knot to the other sling. Okay. I'm going to do it real quick and then I'm going to talk to you guys about it. So just give me 1 second here. Hopefully you guys can actually see this in the webcast, and it may be difficult. Okay, so we've got 2 running bowlines tied back to the opposite side sling. So they both move independently. When you put them on a piece, it allows them both to cinch down, hopefully. Let's see here if we can get it to do it. My piece isn't quite big enough. Let's see if I can find something bigger here. Let's see here. What can that'll work. My handy dandy rope cutter. All right. So as these cinch down, they pull opposing directions as such, and it allows it to lock it in place. If it doesn't slide off, it'll make me look dumb. Right. So it allows it to lock it in place, pulling from opposite directions. It allows the piece to hang perfectly vertical. So what you've done essentially is taken this sling, attach it to that sling, and this sling, this thing. That's why it's called the secret handshake. And in the middle is where your piece would sit. And as it tightens down, it collapses and contracts onto that. Does that explain it as best as I can with a model crane? It's kind of difficult with a model crane. I apologize, folks. I'm trying to do the best I can here. If I had an image to show you real quick, I would, but I just don't have one.
I think that works. I have another question here. They're talking about balls on the crane versus a block for tree work.
Okay, so ball and block are 2 different objects. So you have what's called an overhaul ball, which is where you just have a weight suspended from a single part of line. So this right here, what this crane is showing here, is what's called an overhaul ball. We just commonly refer to that as the ball. We don't say the overhaul ball, it's just the ball. All right. And a block is when you have sheaves here. So it's a pulley and would allow us to go back up this way to the crane, creating 2 parts of line, 3 parts of line, 4 parts of line, and so forth. Both are utilized in crane work a lot with tree work. The difference is when you're looking at capacitive cranes. As you get into bigger and bigger cranes, what becomes the weak point for the lift actually is the hoist line's capacity. even on, say, a GMK 3060 crane, which is a 66-ton all-terrain crane, that load line is only good for 11,500 pounds. That crane can lift a lot more than 11,500 pounds, but the load line in single part fashion is only good for 11,500 pounds. So in order to do a 20,000 pound piece, they put the block on, and they what's called two-part the line, where the piece comes down. And I'm going to try to show this best I can here on our little model. Let's see here. All right. And this now would have a block here. So you'd have a block with a hook, and I don't have one. But now I have two parts of line. So I've created a 2-to-1. So now my 2-to-1 can lift more capacity because now the actual weight that's being effectively felt by the single part line is less than the actual weight. And that's what we're talking to block versus ball. An overhaul ball is used for only one part of line. A block is used for multiple parts of line. Some cranes go all the way up to 10 parts of line on a block. So you have the ability to have lots of different capacities, lots of different configurations there. Does that answer your question?
Yeah,
Whoever
I think
had
so.
that question?
No, yeah, that's a great explanation of it, I think. And if you're ready to go on, I think we are as well.
All right. Moving right along. Section 6, the operator.
Real quick, what book are you working from there?
The book I'm working from here is the TCIA Tree Care Academy Crane Operations Specialist. So this is a certificate of completion book. This is not a qualification or certification, but at the end of the book, there is a quiz you can take. It's at home. All the answers came right out of the book. You take this quiz, you mail it into TCIA along with the core competency sheet on the back. It's filled out for whatever position, be it the operator, the climber, the ground person, everything, whatever you are. And then you would get a certificate in the mail saying you've completed this course. It's really helpful from the OSHA standpoint. It's documented training for the company that shows that you had documented training on this topic. The Tree Care Academy is available for lots of different things, such as chainsaw, chipper, aerial lifts, cranes, so forth. But we're working on the crane one today. All right.
Cool.
I
think that's all my questions.
All right, the operator. Operator is a crucial role in the tree care industry. I'm sure I'm going to spur on some conversation right now, but there was an exemption made by OSHA a few years back that made it where to operate a crane in the tree care industry, you did not have to be a licensed operator. That is only true in the event that you're operating and only picking up raw organic material. That was written in there for more of yarder cranes for logging operations. It was not meant with the intention of the arboriculture industry. So as soon as you hook your crane up to a person and hoist your person, you are no longer lifting raw organic material. You are now lifting actual person. You have to be a licensed operator. If you hooked up to a stump grinder, lift a stump grinder to a backyard, you have to be a licensed operator. So there's a lot of individuals who are operating under this premise that they don't have to have a license to operate a crane in tree care, and that's not true. That is only true if you were only picking raw organic material. For as far as the knuckle boom operators that are running the Mechanol saws or the grapple head saws, there's been a lot of discussion about that. Technically, that is a material handler. That is not a crane. So technically, if you want to play in the gray area, you do not have to be a qualified operator to operate that piece of machinery. But in the event that you have an incident, OSHA's going to look at what training did you have in order to operate that piece of equipment. That's one of the legs that OSHA always stands on is, did you have training in that? So being a licensed operator gives you that training to say you've had training in that. In my opinion, if you're running a knuckle boom and you're running a grapple saw, though you're only picking raw organic material, you are hoisting a piece of machinery. That machinery therefore requires you to have a license to operate. Also, the opinion of if you're going to operate a machinery as expensive as this is, why would you not get an operator's license? So that's just my little soapbox on operator's license. Again, it's America. You choose to do what you want, but that's just kind of how I feel about it. Big things with the operator. One of the new things that came in the Z133 in 2017 is a requirement that anytime you're making a blind pick, meaning you cannot see the piece itself of material as the operator, or you cannot see the person making the cut or doing the rigging of the material, you have to be in radio communication with them. the construction industry, the OSHA construction standard allows us to use spotters to translate hand signals. So you could have somebody in the backyard translating a hand signal to somebody in the side yard who translate the hand signal to somebody in the front yard to the crane operator. The Z133, it's a shall that you have to have radio communication when doing blind picks to eliminate any of those miscommunications that could occur when working in that close proximity to a person. So blind picks, you got to make sure you have good communication through radio communication. Other also is hand signals. For the operators that are pre-tensioning picks, when you're pre-tensioning picks, make sure you use boom up, not hoist up. So in this pick here, if my load is hanging right here, let me just put my sling back on here real quick. Sorry about that, folks. All right. And I'm going to pick this piece up. I would not want to pre-tension my load, meaning I wouldn't want to apply pressure on this by just cabling up. Because what you're going to end up having, which is called boom deflection, meaning my boom is going to bend a little bit. That's normal. As the boom bends, though, this piece is now going to drift further away from my radius. So we want to pre-tension by actually booming up to pull pre-tension, not by hoisting up. So the boom tip actually travels back closer to the crane. So you may not be exactly plumb, but what happens now when the piece is cut free, this piece comes into boom deflection, puts the boom tip directly over the piece should stay perfectly still. You don't want to operate either way, backwards or forwards. We've had documented cases of cranes failing when they've done a pick, a larger, heavy pick. The piece deflected the boom, it drifted outside of the load radius that it was good for, and the crane ended up flipping over. Because the operator did not pull tension and pre-tension using boom up, they just use hoist line. So that's one of the big things from the operator standpoint is being a licensed operator, having good communication through hand signals and radio communication, and also by pre-tensioning, by not hoisting up, by booming up instead. And that's it for section 6. And I know we're got about 20 minutes left. We have got 2 sections to go. Or 3 sections to go, sorry, and we'll be all done for this webinar. So I appreciate y'all hanging with me. Is there any questions in regards to the operator section?
In the operator section, I don't think so. There's a little bit of a discussion going on. There's a little bit of a discussion going on about arborists being crane operators and crane operators being arborists, but I think I think everyone's arguing the same point. You
can be an arborist and be a crane operator, but being an arborist doesn't make you a crane operator.
Exactly, and being a crane operator doesn't make you
an arborist. Correct. Yeah. Yes, there are certain states that require you to have a qualification for that specific state to operate a crane. For instance, Massachusetts has a lift license for Massachusetts. You have to be a qualified licensed operator. And then you have to have your lift operator's license to operate in Massachusetts. There are 3 companies out there that do ANSI approved crane operators licensing. That's CIC, NCCO, and NCCER. I'm a licensed operator and instructor for NCCER. They're the exact same credential between all 3 companies, and they're all 3 recognized by OSHA. There was 4. The 4th one lost its ANSI approval, so now there's only 3. So if you're looking to get your operator's license, make sure you get your operator's license through one of those 3 ANSI approved organizations. All right, moving on to section 7. The rigger cutter. Hold on a second. I got a lot of background noise here. Hold on a second. All right. So the climber lift operator. Now we're looking at the person actually doing the cutting, going up on the crane, and doing those type of things. We're going to talk about tie-in method, how to tie the load to rig the load so it doesn't move, some different chainsaw cuts, and then always communication. So tying into the crane, there's certain ways you want to tie in. Welding on your boom extension, as in this photo here in the PowerPoint, is not ideal. This is a homemade boom extension that was made that this climber is tied into. You can see the metal on there. That's really approved. So don't just go welding on attachments to the end of your crane to get more length. Make sure you're using manufacturer recommendations. And how we tie in, again, we've went over tie-in Big thing is you want to be tied in above the block or above the ball, and then the secondary tie-in point on the hook while in the hoist. So as you can see in this photo here, there's lots of different options for how we tie in. You've got ring and rings. You've got a shackle ring and ring. You've got 2 shackles. So there's lots of different options of how you can tie in with the crane. Again, there's not a right way. There's some wrong ways. Just make sure whatever you're using works in compatibility with your crane. And also, you really want to make sure, ideally, that your tie-in point as the climber is hanging below the overhaul ball or the block. You really don't want to run into a situation where the climbing line comes in contact with the ball or the block and gets pinched or cut or something like that. So you want to make sure your rings are hanging down, generally speaking, about level with the throat of the hook. And that's also where you'd be for your hoist position as well. All right. So some chainsaw use aloft. Lots of different ways to make chainsaw cuts. As many as you probably can think of. But there are some specific ones to crane work we're going to talk about. There's different types of cuts. There's dynamic cuts and static cuts. An example of a dynamic cut would be like a slide-off cut or a snap cut. I have seen tree care operators that have used snap cuts in crane work. It's really not ideal. What you're doing is you're allowing the crane to snap the fibers off, and you're therefore dynamically loading the crane. So though I see people do it, it's not ideal because you have that dynamic load where you really want a nice static load. You want to make it where the clud is completely clean and free, and then the crane lifts the piece away. The crane isn't utilized to separate the piece from the parent material. Some of these are like a static shelf cut, which is where you actually create a notch, a straight through V cut on a shelf. You can do a lift cut, which is where you cut a notch on top of the branch and then cut in horizontal to the plane of the earth below it, creating a flat surface, and then stand the piece up and lift it out. All different options here in the PowerPoint slides you can see for these different applications. One of the most prevalent one that was taught to me by Mark Chisholm is the V cut or the X cut. That is where you take your chainsaw, you come in at 45 or 30-degree angles, sometimes 60-degree angles, depending on what you're trying to accomplish. You cut 2 cuts coming in together and connecting with a little bit of overlap. What that allows to do is it allows the piece to be trapped inside the cut. So now my piece can't move forward or backwards. It's trapped in there. I'm able to pull my saw out, stow my saw, get myself as a climber in a good position for the crane operator to lift the piece out of the cut. Another good option is the sawdust cut. A sawdust cut allows you to use the top half of the bar. Let me grab my saw real quick. So on a sawdust cut, what I'm going to do is I'm going to plunge cut in, and I'm going to walk the saw around the piece, only cutting with the top half of the bar. What I'm doing here is I'm forcing sawdust into the kerf of the cut I'm making. This is really good for butt cuts, the last cut of the day, the last pick of the day. But what happens is now I've shoved all this sawdust in this cut area. The piece is now going to sit on top of the sawdust as well as my chainsaw. I'm able to pull my chainsaw out because the sawdust is acting as a guide or a buffer that won't allow the piece to sit down on top of my saw and pinch my saw. Once you're able to pick the piece slides off just fine, moves away, and all your sawdust also is contained right there on top of your stump. It's easier for cleanup. You don't have sawdust in a complete ring around your tree. You've got sawdust right there on top of this cut. So just another way to do a different type of cut there. Play with different cuts, different operations. You can use the V cuts. You can use the shelf cuts. You can use shelf cut directionally as well. So if you need to swing a piece, you actually can do a side shelf where instead of doing a notch on top, you do a notch more on the side of the piece and then cut your shelf in. And that allows the piece to rotate around and then be picked off. Different operations, the exact same cuts. But again, using different types of cuts, we don't want to use dynamic cuts. We want to stay away from slide-off cuts, snap cuts, and felling notches in crane work. In communicating with the operator as a climber, one of the things that I really enjoy doing as a climber is counting my operator down. So if my operator's in the cab here and I want my operator to swing left, I'm going to swing left 5, 4, 3, 2, 1, hold. And what that allows my operator to do, it allows them to know the destination I'm going by the number I'm counting at, and lets them slow the piece down versus coming to a sudden stop. Because as the crane moves, the piece is going to trail behind or in front of the boom. A good operator can catch the load, which is where the piece is now swung in front of the boom, and they can catch the piece back up so it hangs perfectly still. But in order to do that as an operator, I have to know the point at which I'm going to be stopping. So by counting them down, that allows them to know, okay, well, if we're starting at 5, so 5, 4, 3, 2, 1, hold, they can go ahead and start timing that swing down to catch the load to prevent the load from swaying. Same thing with cable up, cable down, or boom up, boom down. It's boom up, 3, 2, 1, hold. If we're going long distances, say we're swinging from all the way over here, and we're going to swing all the way over to our back outrigger, I may start the count at 10, 5, 4, 3, 2, 1, hold. And that just allows the operator to kind of know the distance we're going to be going and the speed at which they can move in relation to the numbers we're counting from. Just a little trick I've picked up over the years that has helped me communicate better with my operators and know kind of where we're going and how we're going to get there. Next, we're going to talk about the ground crew and their operations. The ground crew is obviously an important aspect of tree care because as a crane operator, you really wouldn't want to get out of the cab every time to unsling the piece. As a climber, you can't get out of the tree every single time to unsling the piece. So you're going to have somebody on the ground to receive the piece that you've cut free. This is a very key position. It takes constant communication and good hand signals. A lot of times in crane work, you have larger operating crews. Sometimes you'll have, could have as many as 5 or 6 people operating on a job site with a crane. My recommendation for there is if you're running the Bluetooth communication systems, divide them into 2 channels. Have your operator, your climber, and your number 1 ground person or your head ground person on one communication channel, and then have everybody else on another communication channel. That way you prevent a lot of the idle chatter, a lot of the background noise, and keep the communication consistent and clear. Obviously, you have hand signals. The nice thing about tree care industry is if I'm the cutter over here and my landing zone's over here, my operator knows where they're taking the material from. So I, generally speaking, don't have to communicate the swing all the way around to where it's going because my operator knows where the landing zone is going to be. So that just allows them to be able to do that a little easier. You can pass it off to them. So if I have it cut, it's free, clear. All right, free and clear to the LZ. That tells my operator, hey, I'm done with you. You can go ahead and swing it and put it down where you need to put it. And the ground person over there can give you the control as far as boom up, boom down, cable up, cable down. The big thing is excuse me. The big thing is our operation range. So when you're making picks, there's a lot of times we don't think about our operating area from a ground person perspective. But the operational area for our pick is anywhere that's going to be inside the drip line in relation to where we're making the pick. So if we're picking the top of a tree out, we don't want anybody underneath that top. Not just underneath the base of the top, but all the branches sticking out. That's the operational area. We don't want people walking underneath pieces. We don't want the operator swinging pieces above people. You want to wait until the piece gets to about chest level. And at that point, then you can manipulate the piece. If you need to manipulate a piece before it gets to ground level, you can use a pole saw, you can use a throw line, get a line in it, move it that way. But you really don't want to just stand down there and do that whole reaching up, grabbing thing. Wait till the piece gets to chest level and then manipulate it there. It just prevents you from being under the load, which is an OSHA violation. Also prevents you from getting hit with dead wood, struck bys, and those kind of things from falling out from a tree, being hosted much further above you than right at ground level.
There's a reason in competitions. Sorry, there's a reason in competitions that if you get underneath the load in one of the Jambo rigging scenarios, that you are immediately disqualified. And that's because it's an OSHA violation and also because it's one of the most dangerous things that you can do. Sorry.
So nope, quite okay. It's a good point, and why we do what we do as far as those things. You don't ever want to be operating underneath a load, whether it be rigging or in crane work. So this piece here we've brought to the ground level, all right, and it's got a little piece stick on the bottom. When we set this piece down as a ground worker, you really want to be cognitive of where you're going to be at, because as this piece comes down, it's going to roll one way or the other. So obviously, maintaining which way it's going to roll helps you. If you look at your sling placement, your slings are always going to try to orient themselves to the vertical position. So this piece is coming down this way. Your sling is now, you can see how the piece starts to move and rotate off. If we come back in from the other direction and start setting the piece down, it's going to sit itself down a little bit nicer, a little bit easier. All right. The piece isn't going to try to find that plumb position. So just know that when you're paying attention to your slings coming down, if it's on the uphill side, it's going to be okay. But if it comes down the other direction and lands more in this position, you have more potential here with the sling being bent back this way. You can catch branches, other material, and this piece could move around and become unstable. Always make sure also once your slings are detached that you detach them by hand. A lot of times I've seen operators pull slings out from pieces. The problem with that is if the piece is sitting over here and I'm using an operator to pull it out, I'm creating that load this way. If this sling is free and clear but stuck underneath a branch or under a log, now this piece swings and you have potential to hit people or hit property. So you really want to make sure to pull the slings out by hand whenever possible, and then have them hang below the crane in a plumb position before the crane boom or hoist up. Just a little trick for preventing damage to the crane, damage to property. All right, we're into the last section. 9 minutes to go. We're on perfect time. Wonderful. Any questions in regards to the climber position or questions in regards to the ground person position?
I actually don't think we have any questions on that. Everyone's just really excited to see you take down that Christmas tree with this crane at the end of the webinar.
Yeah. We'll try that. My Griswold Christmas tree, I had to cut the top off because I got a tree that was too tall for my living room, so I had to hack the top off to put my star up there anyway. But yeah, we'll give it a shot. I think this thing is good for like 30 tons. Yeah, why not? So in rigging and hoisting, which is our last section, we're going to talk about the rules of rigging. We're going to talk about attaching the load, critical angles, and we're going to talk about bridles and the black magic that is bridle slings. So there's some rules to rigging. One of the rules is we have to know our known factors. Our known factors are our crane capacity, the load that we're picking, our sling capacity, be it in a choker configuration or a single angle, our soil PSI, what we're displacing to the ground. Those are all known factors. The one thing that's never a known factor is our center of gravity. So when we attach a piece with a single sling, finding the point where this is going to hang perfectly level, cable up here, is difficult. Our pieces are not uniform. We're not picking up iron. We're not picking up concrete blocks. Our tree parts, very much like this metal hook here, are weighted differently. So our center of gravity changes. So finding the center of gravity with a single sling can be very difficult and take a lot of time and practice to figure out. That's why I highly recommend for a lot of new operators using 2 slings on all picks. Even on a stem pick, doing the secret handshake. You find more center of gravity, more stability that way by trying to do versus doing one pick, trying to do a balanced pick that has the potential to slide and move. This image here shows when you're attaching the load, your load's always going to swing to the uphill side of the sling. So in this configuration here, the sling's on the uphill side. The butt is always going to gravitate to that side. If we were to rotate this around, it's going to do the opposite. The butt's going to sling this way. I'm sorry, this way. Our piece is always going to want to plane itself into this configuration. So make sure when you attach your slings, if you're making a cut on the bottom of the tree, you don't want to be standing on this side where the sling attachment's at, because this piece is going to want to push that direction. If you do the secret handshake, where you come at it from this side, you're being picked uniformly from the middle, the piece is going to lift up nice and straight. So something to look at when you're rigging the piece, look at the canopy, look at the structure, figure out where your slings can be attached to find that center of gravity. We're always trying to find center of gravity. We like to look at sling angles, and we have to remember the effects of sling angles. We talked about the 90 degrees, 60 degrees, 45s, and 30s. When our slings start changing angles, the sling capacity changes. So in a vertical configure or a straight 90-degree angle, there's going to be a different capacity than if we had 2 slings operating at more of like a 45-degree angle. Our capacities are different. So we have to make sure we understand that. Again, the easy way to figure out that capacity for every pick is doing your height, divide the height from your load to your hook, divided by the length of the sling, times the choker capacity, which is we're operating in a choker configuration. It's an easy way to figure out real quick what your capacities are going to be. Lastly, we're going to talk about bridles. This I've built here is a form of a bridle. A bridle is one central attachment point to multiple legs of a sling. This would be called a 4-leg bridle. All right. There's most common are 4-leg and 3-leg bridles. The interesting thing about bridles is in dealing in capacities. When we hang our bridle off our crane, we have 4 independent legs here. When we attach these 4 independent legs, we're not gaining capacity any. Our 4 slings have the exact same rated capacity as that of 3 slings due to the triangle principle of physics.
Can I get you to stand behind that real quick? Can you stand behind it? Because your shirt's black, and there we go. We can see the slings a lot better.
So when you have these 4 slings on here, you're only ever holding all the weight on 3 of them. No matter how balanced this piece is, only 3 slings are catching the full brunt of the load. So therefore, even if you have 4 slings and each sling's rated for, say, 2,000 pounds, your total configuration is not good for 8,000. It's only good for 6,000 because your capacity is only good for the same weight of 3 legs with a 4th leg of a bridle. The 4th leg is purely there to give stability and to limit movement. So it's one of the random things that come along with crane work. It's one thing that operators know that a lot of times our ground workers and our climbers don't realize. But by adding in that 4th leg, we don't gain capacity. We just gain stability. So make sure you're not overloading your slings just because you have 4 on there. It does not give you more capacity. It only gives you more stability. And that's it, folks. That is it for the TCIA Tree Care Academy Crane Operations Specialist. Again, if you have this book in the very back, there's a take-home quiz. All the answers for the quiz are in the book. And then there's also a competency check sheet that your employer can check off for whatever position you hold within your company. And you can go ahead and get your Crane Operations Specialist certificate from TCIA. So that's all I have. Let's talk about some questions. If we have any questions, and we'll go from there.
I actually have a question. I think someone asked about this a little while ago when talking about the secret handshake. It seems to be a little bit divisive about how well the secret handshake works. I'm wondering about how you would calculate the capacity of your slings when you're going to do a secret handshake.
So the way I calculate my capacity for a slings with a secret handshake is the exact same way I would using a single sling on a choker. So I have a sling that has a rated choker capacity of, say, 2,000 pounds. If I have 2 slings, they're still being utilized in the choker configuration, so I'm good for 4,000 pounds. I'm still choking the sling. I'm just now choking it back to the other sling material, but it's still working in a choker configuration. So therefore, it is 2 slings. You do add those slings together for capacity weight, but they're in the choker configuration. I've had really good success with the secret handshake on lots of different types of tree material, being it a very coarse bark material or a smooth bark material. The only time I've ever had any issues is on like a beech tree that's got super smooth bark. And what I do there is I take a chainsaw and just cut in a little bit of a notch, like a Humboldt notch on one side or the other for the sling to sit into, just to keep it from sliding up or riding up any further that way. That's the only problem I've ever had. Other people might have had different problems, but I've never seen those problems.
All right. Unless we get any questions in the next few minutes here, I think that's pretty much what we have on that. Would you like to explain the idea behind your flag here that you have, or your symbol, and where that comes from?
So I come from North Carolina. North Carolina is the home of Blackbeard. And I kind of like everything pirates. I feel kind of like in the tree care industry, we're kind of like pirates sometimes. We do the job that nobody else really wants to do. Very similar to the pirates. Pirates, though, were outlaws. They ran a lot of the trade back in the day that nobody else wanted to do. And that also goes along with my shameless plug here. A while back, I wrote a book on leadership. It's called Leadership for Today. It's got the pirate flag on that as well, because I believe what we do is how we keep life civilized for the rest of the world. Nobody else wants to go out and do the work we do. That's why we do it. But in order to keep the rest of the world civilized, so we are kind of the new age pirate. We get to climb the mast of the ship and swing from the top of the sails, and climb trees. So that's kind of where my use of the pirate flag comes from. That's my contact information, YouTube channel, Instagram. Follow me on Instagram, Facebook, nothing fancy. I'm not like, Tree Care LA that comes up with really cool, catchy ways of Instagram titles and all that. I'm just me. So pretty simple. Thank you for joining me tonight. I appreciate you guys spending 2 hours with me. We had about 120 to 170 viewers this entire time, which is great. And if you guys ever have any questions about this material or anything else in the industry, please feel free to reach out anytime. I love to help out. I love to teach. And see you around.
Yeah, thank you very much, everyone. If you are looking to get your free ISA CEUs, I'm going to be posting the link to the quiz that you'll take in the comments here, and then I'll also post it on our Facebook page. This video is going to be up on Facebook until time in memoriam, and then we're going to be posting parts of this video and the video in its entirety on YouTube in the coming days. So thank you very much, Travis. Thanks everyone for watching, and have a nice night.
Take care.